going to have a very quick look at the AEI GRS Type R transmitter and receiver equipment. Our nearest line at Macclesfield will be decommissioned in the next couple of years. That's the last line that we use this on, but I do realise that some heritage railways actually use some of this equipment for their transmission systems for, I believe, their token and single line controls. So with this equipment that we will come across on heritage railways, and we'll have a quick look at that. This is the Reed Type R transmitter and receiver, standard plug-in base, let's say 930 base, sorry not 930 but 930 style. Slightly different though in that the terminal allocations are labelled as row 10, row 20 and row 30. So this would be say contact 11, this would be contact 12, contact 13, contact 14, contact 15 and contact 16, and then on the next row that would start 21, 22 and so on, and the next row 31, 32 and so on. Pin code, same as on a 930 at the bottom, a lot more substantial though than a 930. And the beauty of this is the reed system is that you have two sympathetic tuned reeds as part of the system. So on this, the transmitter, what will happen is one half of your circuit will put out a transmission of a particular frequency into this coil. You can just make out the reed there in the middle, and that is a filed down reed. And what will happen is the reed will therefore vibrate at the tuned frequency, and because the reed is coupled into this coupling coil here, the vibrations will flow up through the coupling coil, through the coupling bar, which is this piece here, and down into the other coil, where it'll set this reed again in sympathetic resonance, and then create a voltage in the output side. So as long as both are in sympathy with each other, it'll transmit. Now at the receiving end, of course, you have the same setup. Here we have a receiver, one of our receivers, and what happens there, you will set up your own tuned frequency. So if this was 500 hertz, say, this would set up the first frequency resonance in there for 500 hertz, and then your incoming signal from the transmitter at the other end would also come into the second coil, which is hidden behind here, basically the same as this, and that will be at the same frequency, or should be at the same frequency, within 500 hertz, and as long as both are in sympathy to each other, they will then resonate, and you get the output frequency to drive the signalling onto a reed follower relay between 8 and about 17 volts output on that, and that drives the signalling then. So again, these are filed by hand, and there is a link to a video that actually shows this being tuned at one of the railway workshops, which is at the end of this. I'll put that link up, and they're a very fine filing. These have been in use since about 1952, 53. They do suffer with a little bit of the mounting, the rubber mounts up here do get knocked over time. Again, these are spares, so as you can appreciate, you can see that they've been mounted over time, they're starting to droop. When they drift out of the resonance, out of their frequency range, they attenuate, which means that the voltage is killed down, taken down, so that it stops its output. So what you tend to find near the end of these lifespans, you will find the voltage output starts to drift, and that can be a problem with some of the older equipment. Again, if you look, discrete electronic components from the 1950s. The mounting screws that hold these to the back plates are slightly different as well. They are large brass bars that fit through, and what you should have on the front of these then is some OBA nuts as well, and a securing crimp, a seal on the front of these as well. One important thing to note about the Reed system is that the transmitters are mounted in series and the receivers in parallel. So you can take a receiver out to work on the system and it won't drop any other indications out. But if you try and take a transmitter out and you haven't got the balancing resistor, which normally sits across the output line, what will happen is, if that output resistor is not there, you will kill the rest of all the transmitters in the series. So, as you appreciate, across the coils there is a balancer resistor to take it across, so the circuit's not broken. so you can take the transmitter out. That should be wary of that one. And also, another little key interesting point to note, vital and non-vital. So on a vital system, e.g. controlling signalling, twin tuned reeds. On a non-vital system, so say indication only, a single reed on the later newer systems. And this is important because obviously it reduces costs and also reduces the safety, so you only have that on the indication side. So a non-vital system will be indications only, set at transcribers, whereas on the vital system, twin tuned reeds, and that'll be control of signalling systems. To control the power supplies on the Reed system, we have this stabilised, rather large power supply unit, some ginormous capacitors at one end, and our stabilised input-output at the other end. We have 93 to 127 volts AC input and a stabilised 12 volt 5 amp DC output, multiple outputs there, posies, neggies, 3 sets off. So you've got plenty of outputs for your groups there, and one of these will be on each of the groups